Hello everyone. In this video, we're looking to accomplish three things. I want to, number one, go over lab number 3. We'll go through this a little bit more quickly than we did in class the other day, but I want to have a good concrete place for you to come if you get a little lost. What are the steps? What are you trying to accomplish? How are you going to get there? There's, definitely some little, I don't want to say tricks, but little extra steps, little extra extensions that this problem gets us to look at. So we want to, again, do a nice job outlining this. Not to forget that this is due on Monday. You have to turn in your work when you come to class on Monday to get the credit for this lab. So that's going to be our first point. Our second point, I want to talk a little bit more about Monday's test. The problem-solving test that we're going to have on Monday, May 2nd. Make a few points. I want to do a few extra conversion problems, remind you of a few topics just to make sure you're on track. And then last, we're just going to very, very quickly start to mention what's going to happen in Chapter 9. That'll be our next unit that we move into. So just a few minutes. None of this will come up on Monday's exam, but just to open the door to see where we're going. And then next Wednesday, Monday's class will just be the test. So next Wednesday, in that video, we'll really, really get into Chapter 9. So, getting started, actually one last thing I just wanted to mention, the homework from 2A and 2B. Technically, Wednesday would be the last day for 2A's homework, but a couple people asked about handing it in person. You could always drop it off in my mailbox, but I'll extend the 2A deadline until Monday. So if you prefer to hand in your homework in person, that's fine, but 2A will definitely be due on Monday. 2B, we're still looking at next Wednesday as a final deadline. And again, just this quick reminder, we're running out of homework assignments. You need to submit 4, and we're probably only going to have another 2, maybe 3 after we finish Chapter 2. So, lab number 3, dealing with problem solving. I have a slightly better typed up version that I'll include in the email, and I also have posted. But what we are doing here is we are remodeling a room. The room is 20 feet long, 15 feet wide, and 12 feet high. The question is, how much will it cost to remodel the room if carpeting costs $18 per square yard? So we're going to carpet the entire floor. And this is where I just had to add a little bit. We mentioned this in class. We've got a $35 can of blue paint, covers 160 square feet. And in my updated version of this, I made it clear we're using the blue paint to paint the 4 walls, and then we've got a $25 can of white paint that covers 100 square feet, and we're using the white paint to paint the ceiling. So how much will it cost in total to remodel this room with these circumstances? So again, we really did a nice job of outlining everything, so I don't want to rush through it, but to sort of quickly recap and remind you of all the important details. If you are going to find the total cost, we're going to realize it's basically 3 things that we need to buy. We are going to buy carpeting for the floor. So we're going to have to focus on how are we going to spend that money? How much does it cost us to carpet the floor? We are going to use the blue paint for the 4 walls. And then we are going to use the white paint for the ceiling. So we have to figure out how much carpeting we need to buy, and then we have to figure out how many cans of blue paint we're going to need, and then how many cans of white paint that we are going to need. The cost of carpeting plus the cost of blue paint plus the cost of white paint will end up being our total cost. Well, how are we going to get these values? How are we going to get the cost of carpeting and so on? Well, let's take a look. Carpeting costs $18 per square yard. We're getting the price of carpeting based on the area that we are covering. So to get started, we're going to need to figure out the area of the floor. So we've got area is length times width. If we're looking at the floor, well, going back to the dimensions of the room, 20 feet long, 15 feet wide. We're even trying to use those words to help. But again, these two are pretty much interchangeable. But any mention of height or depth, that's where you'd have to, be a little clear, and that would often go with volume. But in this setup, just looking at the floor, oh, and by the way, we mentioned in class the other day, some people draw a three-dimensional picture of the room. That can work, but if you're not a great artist, it's very easy to get lost in that picture. So I'm just going to keep drawing individual pictures. So a two-dimensional picture of the floor looks something like this, where I know it's 20 feet long and 15 feet wide. But now we do run into a quick issue here. And that's what I was saying at the beginning. That's why this is a lab and not a test question. Because if we use these, I'm going to end up with the area of the floor in terms of square feet. The price comes per square yard, so we're going to need some conversion. We're going to either need to convert our area from square feet to square yards, or we're going to have to convert the price from dollars per square yard to dollars per square feet. But that's the extra extension here to fully figure out the floor. The area, and then when we do that area times the rate price, as long as our units are the same, so square feet here would cancel with square feet here, or square yards here would cancel with square yards here, and that would give me the cost of carpeting the floor. Number 2, now let's focus on the blue paint. And remember, this is one quick thing we said in class. We just really need to itemize these 3 things. It doesn't matter which one we do first, second, or third, just that we're considering all of these components. So all of this would go with the floor. Number 2, let's focus on the walls. Well, we've got 4 walls. If we look at the walls, we've got 2 walls that are 15 feet by 12 feet. And then we have 2 walls that are 20 feet by 12 feet. Remember, I'm not trying to draw this to scale. This is just so I could see my side, see what's going on. And remember, where are the 4 walls? You're building up off of the floor. So 12 feet up, 12 feet up. There's one wall. And we've got that mirror image over here, and that's what I'm seeing in this picture. And then up off of these parts of the floor, 12 feet up, 12 feet up. There's this side wall. And I've got that same thing over here. So now in both of these, we can figure out the total area. And then in total, remember, there's 2 of these walls. So whatever we get here, we add that a second time. And then whatever we get here, we add that a second time. Add all those 4 values together. Or again, the order, you already added this twice, you already added this, so combine that. But just to make sure you're getting 4 walls, you don't just get this one wall and this one wall, make sure you get its mirror image as well. But now thinking about the cost here, we need to figure out how much each can of paint costs. We are getting 1 can covers 160 square feet. So you could think of this with this unit, right? It's either 160 square feet per 1 can or 1 can per 160 square feet. But with this setup, that'll allow you to cancel your units better and figure out how many cans you will need. Of course, here's a second catch. The first catch came up over here. We need to do some conversion to make the units of area match the units that the carpeting was being priced at. Over here, the catch is that if you end up with something like 6.2 cans of paint, you can't buy 6.2 cans of paint. How many cans would it need? It's not a natural rounding situation. 6.2, you would naturally round down, but if you only get 6 cans of paint, you're not covering the wall. You'd be short. You'd be missing some. So you have to round up here. And then once you figure out the number of cans, then we could use this. We get the number of cans we need, and then we will have $35 for 1 can, and we will get the price for painting the sidewalls. the cost of painting the sidewalls. And now, last but not least, painting the ceiling. Number 3, thinking about my ceiling. Well, the ceiling looks just like the floor. So I've got 20 feet by 15 feet. Now this is actually a little bit easier because it's pretty much the same thing that we did with the blue paint situation. We got the total area, we use that to figure out the number of cans, and then we could then figure out the total price to buy our blue paint. So similarly here, we're going to need the area, but there's only one ceiling. So we just get that area. In a similar way, we've got one can covers 140 square feet. So I could use that to figure out the number of cans. Same situation. If you need 2.4 cans or 2.7 cans, doesn't matter. You're going to need 3 cans. Anything more than 2 is going to have to be rounded up to 3 to make sure we paint everything. So we will get our number of cans of paint. Sorry. 1 can for 140 square feet. That'll allow us to get the number of cans of white paint. And then we will use $25 per 1 can to get our total price here. So total amount spent on carpeting, total amount spent on cans of blue paint, total amount spent on cans of white paint. Add those together and you will get the cost, the total cost to remodel the room. So don't forget this, everybody. This is worth 5 points, and this 5 points goes right on your final average. Make sure you're handing this in. I do expect work, right? It's not just about getting the final answer. I want to see the work to go with this, and that's what you're turning in. If you want to do it on the actual lab paper, that's fine. But just like the homework, everybody, you could just easily look up the lab from the video or look up the lab just on your computer and then do it on fresh paper and turn that in. So that's big item number 1, going through the lab. Item number 2 is talking about test number 2. Test number 2, as we've mentioned, is in person. It's going to be shorter than test number 1. So what are you expected to be able to do? Well, I mean, just a few quick facts. I still don't have everything finalized yet, but we're looking at about something like 5 total parts and about something like 10 total questions. A couple of them, as we've seen in class, Monday's class was really helpful thinking about 2B and the problem-solving problems, getting some basic pricing. Even as we were going through the lab, we saw some really good examples, figuring out if you have a unit rate, how much something costs. If you know how much something costs, being able to figure out the unit rate, being able to do some basic distance equals rate times time. But we also did some problems with gas mileage. Just again, some really nothing crazy. A lot of it, there are some little ideas with formulas we can try and remember. But the book is trying to get us to use the units, not just expect what the final units are, to use the units throughout the problem, to see that it's not a guessing game. Do I multiply? Do I divide? The units tell us what to do. So I'm definitely expecting to see some work for this. This is a huge section where you need a calculator. You cannot use your cell phone because I need to see that you're doing the work for these things, not just finding answers online. So that'll help get us prepared. That gives us some nice background. But the one thing we didn't really do yesterday were conversions. So I wanted to give you a good sneak preview of that because back when we were doing the basic conversions from 2A, we had bunches of charts. We had this whole chart, which was looking at US customary units, and there's lots and lots of stuff listed. They tried to sort it a little bit by length, weight, volume, but that was just a big, messy chart. We had our metric chart that they made fairly messy. They could have phrased this so much better to make this more helpful. We had a temperature chart. There was a third chart, I believe, converting from US units to the metric system units. So it was very messy. we should be able to think our way through and find anything we need. But for our test, I've always said, I don't expect you to memorize the abbreviations or the conversions. I would give you something like this. So, and this is a good example for our test. I'm not going to load you down. I'm not going to hammer you with lots and lots of extra units. I might throw 1 or 2 extra in there, but it's basically everything you need. So you're going to have to know how to use these charts to answer questions like this. So you've got temperature formulas. So let's start off, do a couple of quick problems to remind ourselves how to use the formulas, because there's a little difference there. Temperature is kind of its own thing. And then we'll do several problems focusing on basic units and doing the conversions. And like I said, it's all located in one place. Everything you need would be found here. It doesn't guarantee everything would be done in one step, but anything you need, there would be a path from the conversions that I give to you. So looking first at temperature. We are converting 90 degrees to 90 degrees Fahrenheit, and we want that in degrees Celsius. So how do we go about that? I want degrees Celsius. I know my Fahrenheit, so I'm looking at this formula. So plugging this in, this is the one we said to be careful with. Some people, it doesn't hurt to show this work just in case something goes off when you're doing your computation. So just to see, and this is why it's also a little different. Everything else we've talked about using the unit fraction to make our conversion, but here we are literally plugging in. Everywhere else we use the units to see how things cancel, but temperature is the exception where we just follow the steps. C equals the Fahrenheit temperature, which is 90, minus 32 divided by 1.8. But here's the warning, everybody. If you do that in order, the calculator understands order of operations, even if we forget. So if I just do this all at once, 90 minus 32 divided by 1.8, I am not getting the correct answer. Because when I hit enter, the calculator knows order of operations, so it goes 32 divided by 1.8, gets an answer, and then 90 minus that answer. That's not what this formula is telling us to do. So that is the wrong answer. What is the correct answer? 2 steps, or use parentheses. 90 minus 32, enter, and that divided by 1.8, that is my answer. 32.2 degrees Celsius. If you want to do that all at once, you have to use your parentheses. Parentheses 90 minus 32. You have to tell the calculator do that first, then divide by 1.8, and we just got the same answer. Second one, well, now we are given the degrees in Celsius and we want to go to Fahrenheit. So now we want this formula. And this one is nicer. This one is definitely more friendly, but you don't get to pick. This situation, you have to use this formula. This situation, you have to use this formula. So this time, we'll get Fahrenheit is 1.8 times 15.3 plus 32. And this is the nice one where, like I said, I could do it all at once on the calculator. I know I use parentheses here because I've always suggested that X is a bad habit. X is just a variable in too many places, so using the star, using parentheses is better. But in this one, just typed it all in, enter, I got 59.54. If I did it in the 2 steps, 1.8 times 15.3, get an answer, plus 32. It's the exact matching answer. Okay, now as we move along, now we're going from gallons to quarts, then we're going from gallons to milliliters, then we're going grams to pounds. Those are the 3 remaining problems we're going to look at. So what we're looking for, well, if I want to go from gallons to quarts, ideally, there will be some conversion listed that directly involves gallons and quarts. And for this problem, That is the conversion that we're going to use. It's a perfect conversion, and I don't mean it's perfect because all the numbers are nice. You know, these are also perfect conversions, even if they involve decimal values. The idea is that it's taking us exactly from the units we have to the units we want. We just have to set it up correctly. So 2.7 gallons multiply, it either goes 4 quarts over 1 gallon or 1 gallon over 4 quarts. Remember, the whole idea, it's not, the 4 has to go with the quarts, the 1 has to go with gallons. So it's really letting the units decide what goes where. I want gallons to cancel. That means gallons goes in the bottom, and quarts would go on top. Remember, I don't care if you remember the abbreviations. That's fine. You could certainly write it all out as quarts. It's nice if you remember them, but it's not necessary. And now that I have my units in the right place, again, 1 gallon, 4 quarts, gallons cancel. We have quarts. The units we wanted is what's left. Numerically speaking, this tells us to multiply. 2.7 times 4, we've got 10.8 quarts. And I know the last couple of classes we've been joking, you know, I can't stress it enough, right? If you don't include the units, you can't get full credit. And if this is a 6 or a 5 point problem, it's got to be at least 2 points to have the right units. So I'm not guessing how I set this up. I'm letting the units dictate, and I'm getting the units I want, and they definitely need to be a part of our answer. Okay, so next, now let's go from gallons to milliliters. So we saw gallons to quarts. We saw a direct conversion that goes gallons to quarts. Well, wouldn't it be nice if we had a conversion gallons to milliliters? Well, I've got gallons to quarts, I've got gallons to liters, I've got milliliters to liters. There's no unit here, there's no conversion, I should say, that is directly taking me from gallons to milliliters. Now, of course, if you look this up, there is such a unit, but my purpose here is to force you to use multiple steps, to think of the path. How are these going to help us? And in this case, this one does nothing for us. Gallons gets me to quarts, but then there's no extra step from here. But if I look at this one, gallons takes me to liters. And then I can go here, and I can go from liters to milliliters, which I'll just abbreviate that ml, just to save a little room here. But that's it. I didn't just jump in and start converting. I looked at what was being offered to me, and I found a path. And now that I have that path, 2.7 gallons, it's gallons to liters. Just like here, I want gallons to cancel. So 1 gallon on the bottom, 3.785 liters. Now I'm in liters like I wanted, but I'm not finished because I want to finish with milliliters, and this conversion will get me the rest of the way. We've got 1 liter is 1,000 milliliters. We've got the ml units that we want. Arithmetically speaking, once again, now it's 2 multiplications. 0.7 times 3.785 times 1,000. We get 10,219.5 milliliters. You know, we have mentioned before having a decent sense of, is your answer in the right ballpark? But again, so many of these, if you remember, a milliliter is a very, very small unit, whereas a gallon is a fairly big unit. Think about a gallon of milk is a fairly large container, whereas a milliliter, if you take your science classes, you have those little droppers that often measure things in milliliters. So this is a very, very small unit compared to this, so it makes sense that there's a lot more. But again, a lot more, if you got 500, that's a lot more than 2.7. So we got 10,000. That's where, we don't have enough background to say, yes, that's definitely right. We got to rely on the arithmetic we're doing. And that's why some people just always double check, right? It's easy to make quick little mistakes on the calculator, accidentally leave out a decimal point, accidentally include an extra zero or forget a zero with all the powers of 10, 100, 1,000 that we've seen. So that's why I'm just saying we want to let the units guide us to our solution. But, you know, the arithmetic that's coming up, it's definitely good to have practice. And I think is a good suggestion. Don't get so obsessed with doing every computation 3-4 times your first go through the test. Get through all the problems. But if you have extra time, a great idea to go back and just double check your arithmetic, double check your computation so that you don't have little calculator mistakes like that. Okay. And last one here, let's go from grams to pounds. Actually, no, we're going to do a number 6 right after this. Yeah, we'll do one more quick one right after this. So what if... Nah, I don't have the right conversions. No, we'll stick with this as our last problem. Sorry about that. We'll do this as our last one. So looking at this one, going from grams to pounds, well, a similar situation to what we saw in number 4. What path do I have to follow? And by the way, I really like this as a review. You know, it doesn't always have to be U.S. customary units to U.S. units, metric to metric. And it's all about the path. So if you have the right conversions in your table, which of course I'm going to give you the necessary ones, you could always find the path regardless of where those units came from. The things you can't do are things like converting liters to pounds. This is a measure of volume, this is a measure of mass or weight, completely different types of quantities. I can't convert inches to pounds or miles to liters. I mean, that's nonsense. That doesn't make any sense. But as long as our units are measuring the same type of quantity, there always is some path. And again, I'm going to provide you that path through some conversions. So here, how are we going to get from grams to pounds? Well, this one discusses pounds, this one discusses grams, and this one also discusses grams. Well, where are we going here? I want to go from grams to pounds. So right here, this one will get me from grams to kilograms. And then this one up here will take me from kilograms to pounds. So that's my path. Quick, just to check, just to realize, looking at the conversions we had, we never used this one. And that's okay. And that's what I mean. I'm not going to load you down with lots of extra conversions, but I might do something like that, have maybe 1 or 2, just to realize what are you using. Don't just try and use everything. You need to identify what you need, which ones will help. So this one never helped. We never had centigrams. We are starting in grams, so we could go from grams to centigrams, but how does that help? It doesn't. It doesn't get us anywhere. So the only 2 that help are these 2. That gets us our path. Now let's do it. We've got 9,840 grams. We're going to need grams to cancel. So we're going to have to put our kilograms over grams. I've got 1,000 grams for 1 kilogram. So 1,000 grams for 1 kilogram. The grams cancel as we wanted. We have kilograms, but we finish. I need kilograms to cancel and pounds to be left behind. So coming up here, that's 1. Oh, I'm sorry. I'm very sorry. I've got that backwards. It's 2.2 pounds is 1 kilogram. I'm very sorry about that. I had that backwards. But we didn't use it, so now we've got it set up correctly. 1 kilogram, 2.2 pounds. So we always set these up as multiplication. Oh, and kilograms cancel. We're left in pounds. But what arithmetic are we actually doing? Here we actually divide by 1,000 and then multiply by 2.2. 9840 divided by 1,000 times 2.2, 21.648 pounds when everything is done. So some nice extra review. Again, thinking about your test, can definitely expect a conversion section, something very similar to what we did here, in addition to those other problem-solving problems that, again, rely on units that we mentioned earlier. So last thing for today in this video, just a sneak preview. Where are we going? What's left? Our last big unit is Unit 9. We are going to talk about the idea of functions. So, again, don't want to get too crazy today. This is going to be next Wednesday. We'll get into it, but just to give you the preview, we are going to see how functions allow us to make mathematical models of a few different situations. In this first section, some of these models will already be given to us kind of to get our feet wet so we could understand what we're doing. And then in the second unit, we'll start to do a little more of that on our own, using some specific situations to help guide us on how to create this model. But we got to start off with some notation. We're going to mention the idea of looking at our variables, and there's a little convention here, but we traditionally use x and y when we start talking about functions, and we use x or sometimes t, especially if time is a situation. Over here for the independent is x or t, and then our y is what we get over here for the dependent. And the idea is, in any of these situations, especially the idea of time flows independent of anything we do, but a lot of things might depend on the time we spent doing something. For example, if we looked at what is your test grade and how much time did you spend studying, the time is the independent variable. The grade you got, we would say, depends on how much time you spent studying. Or you've been driving for a certain period of time. How far did you drive? Again, time flows on its own. How far you drove depends upon how long you've been driving. So in a couple of situations, it feels like every situation we'd have a natural way to identify which one is the independent versus which one is the dependent. And the book tries to push us on that a little bit with a few situations. And again, next week, we'll start looking a little more carefully at these. But that's not always so easy to figure out. And then once we get to the function part, we're a little more accustomed to thinking of these as x-y pairs, and now they're starting to give some specifics. So x the dependent, I keep saying that. X the independent, y the dependent. You always get the dependent second because it depends upon what you input in the first place. So again, those other situations, time and temperature, time and distance traveled, time and grade earned, things like that, the time comes first, and then the second one goes directly with that first value. So this reminds us of XY pairs. We're going to have to graph a little bit. We got a little more specific function notation. We're going to have to see how we can graph these. We're going to get a little more of that notation, making them specific to different situations. A lot of us are somewhat familiar with this y equals f of x notation, but being able to apply that to specific contexts, to talk about how pressure is a function of altitude, how work is a function of distance. So these are some of the things that we're going to see. Again, you notice there's a lot of language. There's a lot of, we're going to get notation. I didn't copy page 519, but we're going to have to be able to make some XY graphs. So 519 has some reminders on how we plot points. I'll remind you how we do that in the video next week. We'll do some of that together. More terms. We're going to introduce formal terms, what we call the domain and the range. The domain, what are the inputs? What are the values that you're using for the independent variable? The range, what are the values of the dependent variable? So there's a little bit of set notation. And then the last thing we're going to do is be given some of these situations and do some basic work understanding them. If we're given a table, if we're given a graph, there's a little bit of units still mixed in here to help guide our thought. But that's the direction where we're going. Like I said, I know I did all of that fairly quickly here because I don't intend for you to actually start looking at Chapter 9. I think you should be spending your time working on the Chapter 2 homework if you haven't already done so, working on lab number 3, using those to start your study for test number 2, but then doing extra study. Extra study, mostly just reviewing your notes, flipping through problems, maybe doing a couple of extra problems, but between the lab and the homework sets, again, reviewing problems, you should be getting enough practice doing them on your own through the lab and the homework sets, but it's still very helpful to review, to remind yourself, to use your experience to help guide you, to remind yourself, how do I start? Where do I go? What are the expected units? How do these units interact? So I think that's my strong advice as far as what you should be doing for the rest of this week. Complete the lab, think about homework, do good study. And again, Chapter 9, it's nice to see where we're going. It's nice to get that sneak peek. If you feel ready for Monday's test, sure, you could flip ahead and start reading, but I didn't assign any homework problems yet. Again, all that will be saved for next week. So that's it, everybody. Let me know if you have any questions, any problems, and I'll see everybody in Monday. Again, one last time, you're bringing in your lab, you're turning that in Monday in class, and then Monday will be the in-person test. I think the test, I'll give you the entire class for it. I think that should be more than enough time. I'm designing the test to be completed in about, I forget exactly, about 45, 50 minutes, but I'll give you the whole class. So you should have plenty of time to work, think, check your work, so we could have a good test. Okay, everybody, have a good week, and I'll see you on Monday.